Hello class 9. Let's solve the remaining sums of exercise 4.3 of linear equations in two variables from your NCERT book. Question number 6. If the work done by a body on application of a constant force is directly proportional to the distance traveled by the body, express this in the form of an equation in two variables and draw the graph of the same by taking the constant force as 5 units. Also read from the graph the work done when the distance traveled by the body is 2 units and 0 units. Since the force is given constant, that is equals to 5 units, so we'll write here as constant force is 5 units. Again, here it is said that the work done by the body on application of a constant force is directly proportional to the distance traveled by the body. That means the distance traveled by the body and the work done is directly proportional to each other. So, we can say that work done is equal to force into distance, where force is a constant value of 5 units. So let the distance traveled be x units and the work done be y units. So if you put those values in the equation, we can get work done y is equal to force 5 into distance x. So these implies y is equals to 5x is the linear equation in two variables. Now we have to draw a graph for it. To draw a graph, we have to find out the coordinates which lies on the straight line y equals to 5x. So for that, let us take different values of x and we will get different values of the y coordinate. When x equals to 0, then we will get the y value as 5 into x, that is 5 into 0. Therefore, y is equals to 0. For x equals to 1, we'll get y is equals to 5 into 1, that is equals to 5. And for x equals to minus 1, we'll get y is equals to 5 into minus 1, that is equals to minus 5. Therefore, we can write these values in the tabular form like this: 0, 0, 1, 5 and minus 1, minus 5 right over here. Now, we can write down those values in a coordinate or ordered pair. So 0, 0, 1, 5 and minus 1, minus 5 are the points which will lie on the straight line y equals to 5x. So when we plot it on the graph, it will look something like this. Always remember to write down the scale. Since I am using a white background, therefore I have not written the scale. But since you will be drawing in the graph paper, you have to write down the scale at the top right corner. You can take the scale as 10 small divisions as 1 unit or 5 small divisions as 1 unit, or according to the space available on your graph paper. So what we have done is, here we have plotted the x-axis and y-axis. From the center we have marked 0, 0. So at center the coordinate or ordered pair will be 0, 0. Neither x moves from the origin nor the y coordinate moves from the origin. Therefore, we can say the coordinate of the origin is 0, 0. Next, 1, 5. So, we'll go one time to the right hand side along x-axis, and since 5 is positive, so we'll go to the positive direction of y-axis, and here we have 1, 5. Again, if we plot minus 1, minus 5, so we can move to the left along the x-axis in the negative direction from origin and come down to the negative direction of the y-axis as well, because we have minus 5. So here is the point minus 1, minus 5. So the minimum number of points that we should plot is 3. We can also plot more than 3 points. So after plotting the points, we'll join them with a straight line. So since all these points lies on the y equals to 5x line, therefore all of them will fall under this straight line. We can also mark this as y equals to 5x. So we can see that we have got AB as a straight line. Now from the graph we get the distance traveled is equals to 2 units. So it has been asked for 2 units. What should be the value of work done? So since the distance traveled is 2 units, we will take x equals to 2 units. So x equals to 2. For x equals to 2, now we will try to drop a perpendicular on it. Since we did not take any other coordinate with respect to 2 comma something, that's why we have to get the value from the graph. It has been mentioned in the question. So to take out any point which lies on y equals to 5x from the graph, we have to extend the line, and we can see that if we take x equals to 2 on the right hand side and drop a perpendicular from the x-axis, then the line will meet the equation at a particular point. From that particular point, again we will drop a perpendicular on the y-axis. That means from the x-axis at 2, we have drawn a perpendicular on the x-axis, or from the x-axis on the line. We met at a point right over here, say A as the point of intersection, and from there we have to drop a perpendicular on y-axis. That means the perpendiculars will be with respect to the x-axis. So this is 90 degree right here, and here also 90 degree. So the perpendiculars are with respect to the x and y-axis. So they meet at a point. So since we are taking with respect of 2 and marking it on the y-axis, therefore we get the value of y as 10. So we can say that y is equals to 10, or work done is equal to 10. We can check the value or verify the value using the equation numerically, but the question was to get the value from the graph. The second part has asked to find out the value of the work done if the distance traveled is 0 units. So if the distance traveled is 0 units, the work done will also be 0. Why? Because we can see that we have already plotted a point at the origin, or 0, 0. So from this particular point, neither we can drop a line because we are already on the line. Okay. So since we are already on the line, or the point x equals to 0 is already on the line, therefore we don't have to go anywhere else. So we are right over here, and we can see the value of y is 0. Therefore we can directly write work done will be 0. Had it been any other number like 3 or 4 or 1, say 1. So for 1, what would have done? So we would have taken x equals to 1. From here we would have drawn a perpendicular on the x-axis. So it would have gone like this and intersected at a point right over here. Now from here we would have drawn a line which would be perpendicular on the y-axis. So if we do so, we'll get the value of y as 5. So if fx equals to 1, x equals to 1, then we can say the value of y, or the work done, would have been 5. So when we will plot the x-axis and y-axis, we should always write down what particular value we are plotting. So along the x-axis, we have plotted the distance traveled, so we will write the distance traveled right here. And along the y-axis, we have plotted the work done. So we have to write like this. Question number 7. Yamini and Fatima, two students of class 9 of a school, together contributed ₹100 towards the Prime Minister's Relief Fund to help the earthquake victims. Write a linear equation which satisfies this data. You may take the contributions as ₹x and ₹y. Draw the graph of the same. Let the amount that Yamini and Fatima contributed be x and y respectively towards the Prime Minister's Relief Fund. It is quite easy to understand that the total amount that has been contributed is 100. So if Fatima has contributed ₹y and Yamini has contributed ₹x, So naturally, the sum of their contribution will be rupees 100. So amount contributed by Yamini plus amount contributed by Fatima is equal to 100. So as per our assumption, x plus y will be equals to 100. It can be observed that 100 comma 0. So if we take the value of x as 100, then y will come out to be 0. And if we take the value of x as 0, then y will be equals to 100. So from there we can say that 100 comma 0 and 0 comma 100 satisfies the above equation. We can also write it in the tabular form. So therefore, these are the solutions of the above equation. So the graph can be constructed like this. We'll take the x-axis and y-axis. Along the x-axis, we have plotted the contribution of Yamini, and along the y-axis, we have plotted the contribution of Fatima. So for the origin, from the origin, if you move to the right hand side, here we have taken the scale of, say, 10 small divisions equals to 20 units, and along the y-axis also 10 small divisions equals to 20 units, or we can take one large division equals to 20 units for both the axes. So when we plot 100 comma 0, it will be right here, and when we plot 0 comma 100, it will be right here. So we can take one more point and we can plot it right here. So if we take 50 for x, y will be also 50. So for 50 plus 50 will be equals to 100. So we can plot it right over here. The point will be lying right here, 50, 50. So if we join the 3 points, then we'll get a straight. Next, in countries like USA and Canada, temperature is measured in Fahrenheit, whereas in countries like India, it is measured in Celsius. Here is a linear equation that converts Fahrenheit to Celsius using the given equation. F is equals to 9 by 5c plus 3 by 2. Draw the graph of the linear equation above using Celsius for x-axis and Fahrenheit for y-axis. Obviously, to draw the graph, we need the coordinates or the ordered pairs. So we have f is equals to 9 by 5c plus 32. We can take a value of c and substitute here, and we will get the value of f. For c is equals to 0, we are calculating and will get the value of f as 32. For c is equals to 15, if we put the value in the equation, we will get the value as of f as 5. And when c is equals to 0, the value of f is coming out to be 14. So the table can be drawn as such: 0, 32, then 15, 5, or minus 15, 5, and minus 10, 14. Sorry, here it will be minus 15. And then we can write down the ordered pairs: 0, 32, minus 15, 5, and minus 10, 14. So if you plot it on the graph paper, along the x-axis we have taken the Celsius, and along the y-axis we have taken the Fahrenheit. So it is very important that we write the information on the graph. Now let us plot the points 0, 32. So if we take from here 0, 32, so we'll plot right over here. Again, we can take 10 small divisions as 10 units. It will be very useful if we take 10 small divisions as 10 units for this case. Next, we can plot minus 15, 5. So if you go in the negative direction, minus 15, 5 in the positive direction, and then we have minus 10, 14. So again, minus 10, 14 will be in the positive direction right over here. So these are the points, this, and these are the points. So we have 3 points. Let's join them. So we are getting this straight line. Okay. So what we can see is that if we join the 3 points, we are getting a straight line. Our answer till now is correct. More questions have been given in the given sum. That is, if the temperature is 30 degree, what is the temperature in Fahrenheit? And we have to obtain all the values from the graph, not by calculation but from the graph. So if the temperature is 30 degrees centigrade, so for the centigrade we have plotted it along x-axis. So just like the previous terms, along the x-axis we will take the value 30, and from there we will drop a line which is perpendicular to the x-axis. So this is perpendicular to the x-axis right here, and let us draw the line or extend the line, and it will meet this particular line which we have drawn at a particular point. From this point of intersection, we will draw another line which will be perpendicular on the y-axis. So we will not draw perpendiculars on this line. We have to draw perpendiculars to the axes. Okay, the line should be perpendicular to the axes here and here, and wherever they meet on the line, that will be the point. Okay, so for 30 degree we have made at this point, and if we drop another line which is perpendicular to the y-axis, it meets right over here. So in the graph we can see that it will be 86 degree Fahrenheit. So we can write from the graph, we have 86 degree Fahrenheit corresponds to 30 degree centigrade. Similarly, question number 3 says, if the temperature is 95 Fahrenheit, what is the temperature in Celsius? So now, since they are talking about 95 Fahrenheit, we have to work along the y-axis, because we have plotted Fahrenheit along y-axis. So if we move towards the value 95, so it will be right over here, 95, the mid value between 90 and 100. Now from here again we will draw a perpendicular to the y-axis, just the opposite way. Okay, so from here we'll draw a perpendicular which is perpendicular to the y-axis. We'll extend the line and it will meet the equation at a point. Okay, the linear equation at a point. So it has made right over here at the red dot, and from here we will again drop a perpendicular to the x-axis. So when we drop a perpendicular on the x-axis, we can see it is meeting the x-axis at this particular point. So that would be the mid between 30 degree and 40 degree. So this is actually 35 degree centigrade. So for the third part we can say, from graph we get 95 degree Fahrenheit corresponds to 35 degree centigrade. This is how we can get values from the graph itself. The fourth one says, if the temperature is 0 degree centigrade, what is the temperature in Fahrenheit? And if the temperature is 0 degree Fahrenheit, what is the temperature in Celsius? For this we can get the values from the graph as well. So if the temperature is 0 degree centigrade, so along the x-axis, that is centigrade axis, we'll take 0. The value is 0 right over here. What is the temperature in Fahrenheit if the temperature is 0 degree Fahrenheit? So for 0 degree centigrade, what are we getting the value for the Fahrenheit? So from 0 we will drop, see, in the previous question the line was passing through the origin, so we didn't have to drop any perpendiculars or any lines. But here we can see the line is not passing through the origin. So from the origin we will draw a perpendicular on the axis. From there we will extend the line and meet the line right here. So this is the point, 0 equals C equals to 0, and from here we will drop a line, and that line is perpendicular to the x-axis and it will meet right here, and it is meeting at such a point where we have the y-axis. So we don't have to draw any further perpendiculars on the y-axis or anywhere else. So we have directly got the value of the y-axis as 32. So we can say for x equals to 0 or 0 degree Fahrenheit or 0 degree centigrade, we'll get 32 degree Fahrenheit, or y equals to 32. So we can write it as well. If we calculate, we'll also get Fahrenheit equals to 32 for C equals to 0. The second part of the same question says that if the temperature is 0 degree Fahrenheit, what is the temperature in Celsius? So if this is 0 in Fahrenheit, again we have to remember we are working with which axis. In the previous question, we were working with Celsius. So we were working with x-axis. Now we have to work with Fahrenheit, 0 degree Fahrenheit, right? So we'll take the y-axis, okay? So from the y-axis, we will draw a perpendicular, which is perpendicular to the y-axis, and we'll extend the line to the equation. So we can say this line or the x-axis is perpendicular to the y-axis here. So we will go along that and we will meet the equation or the linear equation at this point. And here we can see that we are already on the x-axis. So we don't have to extend the line or drop any perpendicular on the x-axis any further. So we are already on the x-axis, so we can get the value, and the value is coming out to be minus 17.8. And if we calculate right over here, here also we are getting minus 17.8 degree Celsius for F equals to 0. That is Fahrenheit. So this is how we can find out the value from the graph. So for this particular sum, we have to get the value from the graph, and we can also show the calculation here. For question number 5, is there a temperature which is numerically the same in both Fahrenheit and Celsius? That means the temperature will be same for both Celsius and Fahrenheit. So if we go along this particular equation, there will be some particular point or ordered pair where both the x coordinate and y coordinate will be same. So we can, if we follow the equation properly on the graph, then we'll get right here minus 40 comma minus 40 is actually the same. You can also calculate it, but you have to show it on the graph paper as well. So if we take f is equals to c, then in the equation f is equals to 9 by 5c plus 32, we'll put f equals to c. So instead of c, we have put the value f. Now if we just keep on calculating, and we will get the value of f as minus 60 by 4, and ultimately Fahrenheit will be minus 40. So since f is equals to c, that is the Fahrenheit value and the Celsius value, both will be minus 40. So here we can plot minus 40 comma minus 40 will be the point where both the degrees will be same. That's all for today. Hope you have all understood. Thank you everyone for watching the video. Bye bye.